Bismillahirrahmanirrahim. In this lecture, I am solving problem 6.29 from the book Fundamental of Thermodynamics by BORGNAKKE. So, the statement of the problem is a diffuser receives an ideal gas flow at 100 kilopascal. So, first here is diffuser and and in the diffuser the process occur as throttling process. In throttling process enthalpy is constant H1 is equal to H2 at 100 ideal gas है at 100 kilopascal P1 is equal to 100 kilopascal and T1 is equal to 300 Kelvin with a velocity of 250 meter per second. Ci inlet velocity is equal to 250 meter per second and the exit velocity Ce is equal to 25 meter per second. Determine the exact temperature if the gas is argon, helium and or nitrogen. So find T2 for argon, find T2 for helium and find T2 for nitrogen. So there are some assumption in the problem. Number 1, process is adiabatic, no heat gain or loss. Number 2, steady state process. Steady state process. And number 3, potential energy is negligible. So according to these assumptions, the steady state equation is H1 plus C1 square divided by 2 and potential energy is negligible is equal to H2 plus C2 square divided by 2. H1 and H2 are enthalpies and C1 and C2 are inlet and exit velocities. This is C1, this is C2. So we know that H1 is equal to CPT. So we can write H1 is equal to CPT1 specific heat constant at constant specific heat capacity at constant pressure. T1 is inlet temperature. C1 square divided by 2 is equal to H2 is equal to CPT2 plus C2 square divided by 2. So now we have to find T2, so rearrange this equation. So CPT2 is equal to CPT1 plus C1 square divided by 2 minus C2 square divided by 2. So CPT2 is equal to CPT1 plus I can write this as C1 square minus C2 square divided by 2. Now to find T2 both sides divided by Cp. So this is equal to CPT1 divided by Cp plus C1 square minus C2 square divided by 2 Cp. So T2 is equal to T1 plus C1 square minus C2 square divided by 2 Cp. Now first we find T2 for argon. So Cp are constant values. There are some constant value for argon. Cp is equal to 0.5203 kilojoule per kilogram per Kelvin. For helium, Cp of helium is equal to 5.1926 kilojoule per kilogram per Kelvin, and for nitrogen, Cp is equal to 1.039 kilojoule per kilogram per Kelvin. So T2 for argon is equal to T1, this is the equation, T1 plus C1 square minus C2 square divided by 2Cp of argon. So T2 of argon is equal to T1 is given to us as 300 Kelvin plus C1 is 250 meter per second square, C1 square, C2 square, C2 is 25 meter per second whole square, divided by 2 Cp per argon is 0.5203 kilojoule per kilogram per Kelvin. So kilojoule is equal to Newton meter per kilogram per Kelvin. So T2 per argon is equal to 300 Kelvin plus 250 square is equal to 62500 meter square per second square, minus 25 square is 625 meter square per second square, divided by 2 multiplied by 0.5203. This kilo is equal to 1000 and Newton is equal to kilogram meter per second square, and this is meter and this is kilogram into Kelvin. So kilogram will be cancelled with kilogram. Now T2 per argon is equal to 300 Kelvin plus the difference of these two values is equal to 61875 meter square per second square, divided by 2 multiplied by 0.5203 multiplied by 1000. So this is equal to 2 multiplied by 0.5203 multiplied by 1000 is equal to 520.3, and this is meter square per second square into Kelvin. So meter square will be cancelled with meter square, second square will be cancelled with second square. So T2 per argon, now simplify this and add with 300. So the final answer will be 359.46 Kelvin. This Kelvin is in double division. So this is the final exit temperature for argon. Now the exit temperature for helium is equal to, formula is T1 plus C1 square minus C2 square divided by 2 Cp per helium. So putting values, T2 for helium is equal to T1 is 300 Kelvin plus C1 square is 250 meter per square second minus C1 is 25 meter per second square divided by 2, and Cp per helium is 5.1926 kilojoule per kilogram per Kelvin. So kilo is equal to 1000 and joule is equal to Newton meter per kilogram per Kelvin. So T2 per helium is equal to 300 Kelvin, 250 meter per square second minus 25 meter per second whole square is equal to 61875 meter square per second square divided by 2 multiply by 5.1926 multiply by 1000 is equal to 5192.6, and Newton is equal to kilogram meter per second square, and this is meter, this is kilogram, and this is Kelvin. So kilogram will be cancelled with kilogram, and this is meter square will be cancelled with meter square, second square will be cancelled with second. So per Kelvin will be equal to Kelvin. So 300 Kelvin plus this Kelvin, which will be equal to 305.957 Kelvin. This is the exit temperature per helium. Now exit temperature per nitrogen, formula is T1 plus C1 square minus C2 square divided by 2Cp per nitrogen. So putting values, T1 is equal to 300 Kelvin, C1 is 250 meter per second whole square, C2 is 25 meter per second whole square divided by 2 multiplied by Cp per nitrogen is 1.039 kilo. Kilo is equal to 1000. Kilo is equal to 1000, and joule is equal to Newton meter per kilogram per Kelvin. So T2 per nitrogen is equal to, this numerator is equal to 61 300 Kelvin plus 61 875 meter square per second square divided by 2, and 1.039 multiplied by 1000 is equal to 1039. Newton is equal to kilogram meter per square second, and this is meter, and this is kilogram and kilo. So this kilogram will be cancelled with kilogram, meter square is cancelled with meter square, second square is cancelled with second. Per Kelvin is in the double division, so it will shift to numerator. So T2 per nitrogen is equal to 329.77 Kelvin. So this is the exit temperature per nitrogen, and this is the end of the problem. And for more problem, please like and subscribe my YouTube channel and share with your friends. Thank you.